Hello, everybody. Thank you for taking the time to attend my presentation today. My name is Matthew Zimmerman. I'm one of the founders of Farsounder and Vice President of Engineering. My colleagues Heath and Cassie are joining us today as well in the chat, and they'll be happy to monitor and answer any simple questions along the way. And of course, we'll open it up to any longer or more complex questions at the end. Today, I'll be discussing 3D forward-looking sonar and how it relates to polar navigation in general, as well as how my company's products and technologies can be applied. First, I want to start by exploring why 3D sonar. We all know that groundings and collisions cost lives and money. Many of these incidents also cause significant environmental impacts. The polar regions are areas that are difficult to operate in, and the environments are delicate. This means that responding to incidents in the Arctic and Antarctic is a much bigger challenge than in other parts of the world. We're seeing increased vessel operations in these regions, and it's clear that it's only a matter of time before we see this next grounding or collision, which results in a loss of life, high financial costs, or massive environmental impact. I think we're probably also all in agreement that this engagement in polar regions will only continue to grow. Therefore, we as an industry and as a society need to develop and deploy technologies to reduce these risks. Part of the problem is that navigation in polar regions is still greatly unknown. Yes, there have been a lot of advances in radar, GPS, electronic charts. However, those technologies are only part of the puzzle. 3D forward-looking sonar provides the most basic navigation information, which is what is under the water ahead of the vessel. Sonar is a very broad term, so let's take a few moments to understand how 3D forward-looking sonar differs from other sonar technologies and other sensors on board the ship. So every vessel pretty much has a standard echo sounder. This is a type of sonar that has a single beam and looks straight down below the vessel. As you can see from this illustration, it does not do anything to detect the rock ahead on the seafloor. Every larger vessel has a radar looking above the water, and obviously, still, it does not detect the rock on the seafloor below the water. Some vessels have scanning sonars, also just sometimes called sonar. Scanning sonars are technically forward-looking sonars since they can be pointed forward, and they are sonars. But they've been primarily designed for deep water fishing and don't provide a reliable navigation picture. Also, as you can see, it's pretty easy for them to not detect the rock ahead of the vessel like we see here. To be an effective navigation tool, a forward-looking sonar must have a wide field of view and a fast update rate. Additionally, they have to be capable of sensing from the seafloor all the way to the sea surface with a single ping. This illustration, you can see the rock on the sea floor being detected by this type of forward-looking sonar. And this is exactly what Farsounder's unique technology can do. So let's take a quick look at what our sonars are capable of. Here's an example of our product's 3D sonar display. We generate this complete image ahead of the vessel to navigationally significant ranges with a single ping. The idea of this capability is simple. However, the development of our capabilities was not that easy. As I mentioned, I'm one of the founders at Farsounder, and I helped found Farsounder 20 years ago and have been working on the development of our core technologies since even before Farsounder was born. So our technology has been under development for over 20 years now. And today, we have a true 3D sonar product, and we've been shipping products to customers all around the world since 2005. Our customers use our products to avoid a wide variety of navigation hazards, including obviously icebergs when navigating in polar regions, large whales, rocky pinnacles, shallow sea bottoms and coral heads, lost shipping containers floating at or just below the sea surface, and other unmarked obstacles such as submerged breakwaters. Our products are intended to provide the vessel operator with a clear picture of what is under the water ahead of the vessel. Farsounder sonars operate at navigationally significant ranges and provide a complete three-dimensional image with a single ping. These systems can map the seafloor out to at least 8 times the depth of water below the transducer, as well as detect in-water targets out to the full range of the sonar. Let's take a quick look at the software display found in all of our navigation products. As we see in this clip here, we can see the seafloor as well as a number of bridge pilings ahead of the vessel being detected by one of our sonars. The seafloor has its color mapped to depth, where blue is deep and yellow is shallow. On the left-hand side of the screen, we see our chart overlay display. Everything inside the sonar's field of view, that pi wedge, is real-time information ahead of the vessel. This display also includes a bathymetric trail to the side and behind the vessel. We call this our local history map. On the right-hand side of the screen, we see the same real-time sonar image ahead of the vessel inside our 3D sonar display. The user can rotate the image in 3D via a mouse or trackball, and a 2D slice through the 3D image is shown at the bottom of the screen in our profile display. The user can select any bearing they choose using the profile selector. That's the white plane shown in the center of the 3D image. We use the same software across our entire line of navigation products. Our navigation sonars are installed on a wide variety of vessels and consist of the Argos 350, Argos 500, and Argos 1000 sonars. The primary differentiator between our models is range, hence our cleverly named product models. These 3D forward-looking sonars have a maximum operating range of 350 meters, 500 meters, and 1,000 meters, respectively. The maximum operational speed and field of view also vary accordingly with each model, as you can see in this chart. Each of the Argos series sonars use a product-specific in-water sensor, which we call the transducer module. The primary difference between these units is the number of elements in their receiver arrays. More elements result in higher resolution and capable of operating out to longer ranges. The Argos 350 transducer module has a receiver array with approximately 50 receiver elements. The Argos 500 has approximately 100 elements in its array, while the Argos 1000 has a receiver system with approximately 200 elements. All our Argos sonars utilize the same sophisticated sonar processing and display software and the same type of inboard equipment, which we call the power module. A Farsounder supplied cable is used to connect the transducer module to the power module and features an underwater wet mateable connector, and this allows the transducer module to be installed or removed by a diver. So now that I've introduced you to what our technology and products do, let's take a few moments to talk about how they do it. All our forward-looking sonars are based on 2D technologies, much like a radar image, but underwater. These types of sonars can only generate an image of signal level versus range and angle. In this example I'm showing here, we took real signals from a single ping from one of our sonars and processed them with traditional 2D beamforming processing on the left and our 3D beamformer processing on the right. This ping was transmitted with the vessel approaching alongside a commercial pier, and in the 2D image, we can see a strong set of reflections corresponding to the location of the pier. However, with only a 2D sonar, we can't determine how deep the object is, only where it's located. In the 3D image, though, we can see this same feature in the horizontal slices as well as the seafloor of the vessel in the vertical slices. We can also see the raised structure of the pier wall, showing it extending from the seafloor all the way up to the surface. As you can see, the beamformer processing output is pretty complicated, and it takes some effort to interpret the data. This is why we've developed further processing stages, which we call target modeling, and these basically extract relevant 3D information from the 3D data. On the right, we can now see the same ping using our standard 3D output from our system. In this case, the target was a pier wall and clearly visible above the water. However, if this was an underwater obstacle, traditional 2D processing would not be able to tell you if the object was deep enough to be safe or shallow enough to be dangerous. There are a number of applications relevant to polar waters that can be addressed with existing forward-looking sonar products today. These applications all relate back to that same basic question of what is under the water ahead of the vessel. Some hazards are stationary but not charted. We know we have tremendous areas with little or no chart data around the world. Some hazards are transient, like ice or boulders pushed by ice. Some hazards are poorly positioned relative to the vessel. Whether the surveyed location is wrong or the vessel's current location is not accurate, a known hazard may not be where the vessel operator thinks it is. And of course, some hazards are new. Post-disaster debris from land, other ships, lost drilling rigs, and so on can be introduced to routes that were previously clear and now become unknown. You'll notice that most of these applications are not unique to polar regions, other than the ice, but they certainly are amplified in these locations. 3D forward-looking sonar, when used in conjunction with the other standard navigation tools like radar and ECDIS, can help mitigate these hazards. Of course, we don't want to propose a solution to reduce one type of environmental impact by introducing a new environmental impact. As I mentioned earlier, the term sonar is very broad. Anything that uses a pressure wave to make a measurement is a sonar, and most legitimate scientists are in agreement that some types of loud, low-frequency sonars can harm marine life. Farsounder sonars are not like these. Our products are out of the hearing range of the great whales and are quieter than a dolphin's own biological sonar. Additionally, our products operate at a lower power output and slightly higher frequency than the most common and accepted commercial echo sounders. We take pride in making sure that our products are environmentally benign. In fact, our early motivations were environmentally driven. Our first prototypes were developed with the goal of reducing ship strikes and avoiding oil spills caused by groundings and collisions, and of course the whale ship strikes severely hurting or killing those whales. Farsounder is located in Rhode Island, and whale ship strike is one of the leading causes of death for the endangered North Atlantic great whales that make their home off of our coast. We also experienced a local oil spill that was quite large by local standards, small by global standards, that was caused by a barge hitting a rock. These events really helped drive our product development. And now these products are installed on a wide range of vessels operating from hot tropical waters all the way to both polar regions. Many of Farsounder's customers have ice-classed hulls and utilize our standard fixed mount installations. A few of our customers have full ice-breaking capabilities and deploy our sonar on a hoist. In all cases, these customers rely on their Farsounder sonar to help them navigate safely. And these customers include passenger vessels, research vessels, yachts, militaries and coast guards, survey vessels, OSVs, and so on. So I want to take a quick look and show you how our systems are installed on a variety of these vessel types. Here are some examples of vessels with larger bulbs. The two hulls shown on the left and the right are photos of ice-classed passenger vessels. It's even possible to install on a bulbous bow to the side of the stem. We found this picture of one of our customers on the marinetraffic.com website. Of course, installation is possible on vessels with smaller bulbs. The large picture shows an Argos 500 installed on a 62-foot composite hulled Nordhavn. The other two pictures show vessels with medium-sized bulbs which have Farsounder equipment installed. This vessel is another ice-class vessel. This time it's an example of a straight bow with an Argos 500 installed on the center line. Some of our customers have very straight axe bows. These pictures show an Argos 1000 installed with a rectangular fairing tube on the vessel's center line. Yet another ice-class vessel here. Here are a couple of examples of vessels with raked bows showing the fairing installed on the center line. And you can see the top of the fairing tube is mated flush with the stem. Of course, also with a raked bow, you can have the fairing installed to the side of the stem. The picture on the right shows an Argos 1000 installed with a rectangular tube fairing, and the left shows Argos 500. We have complete drawing packages and example installation drawings for all of our sonars, as well as an installation design guide to walk our customers through the important details about installation. We also offer a complimentary review of installation design drawings so that we can work with your naval architects and the shipyard to ensure a simple and easy installation. By checking these details early in the project, we can prevent issues from coming up later in the project. A couple more pictures to show you of a few other types of vessels. Here's another vessel with a raked bow, and this time we see an example of a fairing that was installed on the center line, but forward of the stem. This vessel was a quick refit and the stem was not cut. Only a small cable penetration passes through the hull. And then inside the hull, the cable runs in a conduit up above the waterline to prevent any water ingress. Here's another example of the fairing installed forward of the stem on a new build. Note that there's a camera fairing also located, but below the sonar fairing. Locating the camera housing below and behind the sonar prevents turbulence generated by the camera housing from interfering with our sonar. Again, another example with sonar and camera housing. In this case, both fairings are recessed into the hull through the stem. And lastly, here's a picture of a fixed installation on a composite hull. This is a Argos 350 that was refit on a 72-foot Princess. And the curved face of the Argos 350 fills that front opening. As I mentioned before, a few of our customers do choose to install their sonars on a hoist. This can be useful for vessels that are actually out there doing full ice breaking applications or other special needs. On the left is an ice-classed yacht with an Argos 500 hoist, and on the right is the RSS Sir David Attenborough with an Argos 1000. They are a full icebreaker, as well as Ponant Cruise Line's icebreaker. You may have seen in social media recently the two of them met down in the Antarctic working together to break ice down there. Some pretty cool pictures seeing two of our customers breaking ice together. The Argos 350, we've actually designed to fit inside a standard 10-inch diameter sea chest. And when it's intended to be used with a hoist, the unit can actually be supplied with its connector on top rather than on the rear of the unit like we see here. There are blind tapped mounting holes integrated into the top of the transducer module for connecting to a hoist mechanism, and there are also blind tapped holes on the bottom to allow for attachment to an exterior cover plate to the sea chest. This means that any suitably sized hoist mechanism can be used with a simple adapter plate to mate between the hoist and our transducer module. Also, we have a partner in Denmark, C4R Maritime Solutions. They are the company that supplied the large hoist mechanism for the Sir David Attenborough and the Ponant icebreaker. They have a smaller off-the-shelf hoist design specifically for the Argos 350. Of course, our unit can be deployed on any suitably sized hoist mechanism with a simple adapter plate, though. C4R solution does allow for really clean hull lines, and with that custom cover plate on the bottom, you can actually make it so it's flush to the hull when retracted. As I'm sure you all know, our core value proposition is the real-time forward-looking capabilities of 3D forward-looking sonar. However, I also wanted to introduce you to some of the data recording capabilities of our products. Some of these I'm going to talk about are available today, and some of these features are going to be launched later this year, but I think it'd be valuable to talk about them because they really do apply directly to many polar applications. As I mentioned a moment ago, our focus is real-time sensors ahead of the vessel, but our products do include what we call our local history mapping feature. This is essentially a bathymetric survey output of where the vessel has been recently, and it's similar to the output of a standard down-looking survey sonar. This can be used for retracing a difficult passage through a treacherous route, or an anchor survey before dropping the hook in an unfamiliar location. In our current software, local history supports the last hour of the sonar records. We have some new software updates that are planned for later this year that are going to enable the ability to store and recall more than just that one last hour. And in the future, we even envision the ability to store and recall and share data across a fleet. This could be exciting for commercial operators who are sharing data between all their Farsounder equipped vessels, or even yacht customers who are sharing data across a common vessel management company or a cruising club. Besides the local history mapping capabilities built into our software, we also have a program which we call our Expedition-Sourced Ocean Data Collection. This is an opt-in program for select customers who are traveling to exotic locations and are interested in contributing to science and want to participate in making the systems better. As part of this program, we send participants a USB hard drive, which records all the raw data received by their system. And when the drive is full, it's sent back to Farsounder for compilation. I want to stress this program is opt-in only. Otherwise, our systems are not recording anything that is sent back to Farsounder. Here's a map of some of the data collected by our customers. To date, over 50 terabytes of sonar data have been collected out in the field, and we have about another 70 terabytes of drives recording currently. This data is included in the continual testing of our algorithms to allow for more examples of different sonar locations, different sonar types, and different conditions, so we can always improve and make our algorithms better through software. Additionally, a subset of the data is submitted to NOAA and the IHO through our work with the IHO's Crowdsourced Bathymetry Working Group. We are a trusted node of the IHO's Data Center for Digital Bathymetry, and all of the contributions that we send to the IHO database are available globally for use by anybody in the public. And this IHO database is also part of the Seabed 2030 campaign, which is an effort to map the world's oceans. So a lot of our customers really like the fact that they can contribute to global safety, even for non-Farsounder users and for scientific knowledge about our ocean world. Our latest initiative is to start collecting more and more data around Antarctica. This initiative is completely an internal R&D project. We just think it'd be really interesting, and we're looking forward to contributing this to the global community. Right now, we have 5 customers who are collecting data on board their ships during their current Antarctic cruise season, which is wrapping up just about now. These are cruise ships, each making multiple cruises through the region, and it'll be a totally unique data set with hopefully overlapping surveys, and this could be really high value to various scientific endeavors. Farsounder is hoping to repeat this in future seasons and even expand to more vessels. And this would be really cool because it would provide data over this very unknown area, as well as a function of year-to-year season. So we can actually see how the Antarctic seafloor would be changing over time. So some of you might be wondering, how can crowdsourced bathymetry be useful? Well, our sonars can clearly detect major features and navigation hazards, and this information would be invaluable for areas that are not charted or not recently charted. Hydrographic offices can look for discrepancies between what crowdsourced data provides and what their previous surveys show, so they can help plan their official survey needs. In fact, the Canadian Hydrographic Service is currently working on an update to their chart 7053 that will incorporate data collected from a Farsounder customer during their voyage through the Northwest Passage. It's just a proof of concept for them, but they're really excited about where that can go. And in another example, even closer to home, this animation shows some of our data that we've collected locally in the Narragansett Bay. And it turns out that even in this well-traveled area, NOAA does not have complete coverage. The light blue spots represent gaps in the data that NOAA has available and contributed to the 2030 Seabed 2030 campaign. We're currently in communication with NOAA's National Centers for Environmental Information about how best to contribute data that we've collected in areas missing from NOAA's coverage. And lastly, for users who are focused on professional survey applications, we also offer direct integration with Kinsey from QPS. This is a real-time connection into the QPS ecosystem, and far sounder data can be used similar to any other traditional multi-beam survey sonar inside their software systems. So in conclusion, we know that owners and operators are always concerned about minimizing risk while navigating. And I hope that I've been able to show you all how Far Sounder's navigation sonars are key contributors to vessel safety and are easy to use and install. By helping to avoid collisions and groundings, we can minimize ship downtime, reduce injuries, decrease environmental impact, reduce the frequency and severity of claims, save a variety of indirect accident-related expenses, and all these things mean contributing to an improved ROI. Regardless of whether you're a commercial operator or a yacht owner, keeping your vessel in operation longer and more safely really makes economic sense. So thank you for taking the time to learn about our 3D forward-looking sonars and their applications to polar navigation. Once again, my name is Matthew Zimmerman from Far Sounder, and I'd be happy to answer any questions that you may have. My colleague Cassie will be helping to moderate and read those questions out to us. So thank you.
Yes, Matt, I'm here, and great presentation and very informative. We do have a couple of questions that have come through. First, have you installed transducers on the keel of a sailboat?
We've done a few large sailing yacht projects with our Argos 500 and Argos 1000 sonars. One of them was a fairing that has the sonar integrated directly into the keel. The other one has a hydraulic drop keel, and they installed the sonar fairing in the small portion of the keel that is actually stationary, where the drop keel comes out of.
Great. And we have one, can this be retrofitted on an existing commercial bulk carrier?
Great question. We do about 50% refits with our customers, and even many of our new builds are refits from the technical point of view. And many times the hull is completed before the electronics package is decided upon. And so even if the hull has never actually been in the water, it is sort of a refit project for the shipyard. But true refits, so vessels that have been out for a while and coming back into a dry dock period, very easy to install a fairing at that point.
Great. Unless anyone else has any questions, I think that's it. We don't have any other at the moment, so.
Well, thank you everybody for taking the time to join us here. I really appreciate it. And as always, please feel free to call or email or ping us on social media if you have other questions that do come up. Thank you very much and have a great rest of your day.